Good morning, everyone. My name is Neha Bhartari, and I'm a student of Masters in Chemistry from NIT Hamirpur. I have opted for engineering chemistry, so my topic is some basic concepts of chemistry. So basically, I have taken the most basic topics, the first one being the mole concept. Now, for the mole concept, in order to understand this from a very basic point of view, for example, if we say a dozen, what number comes to our mind is the number 12, right? Similar is the thing with mole. So if we say mole, what we mean is that we mean 6.022 into 10 raised to the power 23 entities. If we say a dozen of donuts, what we actually mean is that 12 number of donuts. And if we say, similarly, if we say a mole of donuts, what we mean is 6.022 into 10 raised to the power 23 number of donuts. So basically, a mole is just a unit to calculate the number of atoms, molecules, ions, or electrons, or any species present in a particular species, right? So this number itself is also known as Avogadro number or the Avogadro constant. Now, I have categorized the mole concept into two parts. Number one being the mole in terms of mass, and the number two being mole in terms of volume. So, firstly, we will study about the mole in terms of mass. Okay. So here basically, 1 mole is equal to the molecular mass or the atomic mass of a species, which in turn is equal to the Avogadro number. So what I mean is, if I have 1 mole of carbon, now 1 mole of carbon, the atomic would be equal to the atomic mass of carbon, that is 12 gram, and which in turn would be equal to the Avogadro number of atoms. While if I say 1 mole of copper, then it would be equal to the atomic mass of copper, that is 63.5 gram of copper, which in turn would be equal to the Avogadro number. Now here you can see with the help of the diagram. Now in both the cases, the amount is 6.022 into 10 raised to the power 23 atoms. Right, because 1 mole of carbon and 1 mole of copper, both of them contains this particular number of atoms, while their atomic mass could be different. Okay. Now, in this slide, as you can see that I have taken 1 mole of these particular elements, whether it is zinc, carbon, magnesium, or copper. All right. So basically, this is 1 mole of these particular elements. Now, 1 mole of these particular elements have different atomic masses, but the entities, the atoms present in them would be same. That is the Avogadro number, or 6.022 into 10 raised to the power 23 atoms, although their atomic mass are different. Okay. Next, we will come to the mole in terms of volume. Okay. Now, in case of mole in terms of volume, it is important for us to first know about NTP. Now, NTP is normal temperature and pressure conditions. In this condition, the temperature is 0 degrees Celsius and the pressure is 180. So, it says that for 1 mole of an ideal gas at NTP, at normal temperature and pressure conditions, the volume is 22.4 liters, right, for an ideal gas. So, if we have 1 mole of helium, nitrogen, or methane at NTP conditions, then their volume would be 22.4 liters. All right. Now, as you can see in the figure, their mass of gases are now their molar masses are given, but the number of gas molecules would be same, right? So through this diagram, we can, this diagram is basically the application of both of these two topics what we have studied. The first one is the mole concept in terms of mass, right? And the second one is the mole in terms of volume, because all three of the gases have same volume at NTP, and coming to the number of gas molecules, all of them have the same number of gas molecules, right? Although their atomic masses are different. Now, the most basic formula what we use in the mole concept is number of moles is equal to the given mass divided by the molar mass. Okay. Now, here I have taken some questions of JEE Advanced. Now, as you can see in this question, it is being mentioned that which has the maximum number of atoms, right? We have to calculate the maximum number of atoms. So there's no need to calculate the number of atoms. We can simply get the answer by calculating the number of moles. So we will calculate the number of moles according to the formula we have just read. That is a number of moles is equal to the given mass upon molar mass. Now the given masses are already given in the options. the molar masses are given in the brackets. So we will divide the two and we'll get our answer. That is the number of moles. Now, as you can see in the option, that option A has the maximum number of moles. So here, the correct option would be option A, right? Because since A has the maximum number of moles, ultimately it will have the maximum number of atoms, because the number of atoms it would have would be equal to 2 into the Avogadro number, right? So the correct option would be option A. Then we come to the next question, which is, now here in this question, we have given the ratio of masses of oxygen and nitrogen. Okay? It is given, basically it is given 1:4. So we will, using our basic mathematical concepts, we will assume the mass of oxygen to be X. We will assume the mass of nitrogen to be 4X, right? Because the ratio is given to us 1:4. Now, using our basic formula, number of moles is equal to the given mass upon molar mass. We will take the given mass of oxygen to be X divided by its molar mass, that is 32. Similarly, we will do the similar thing with nitrogen. Now, in order to calculate the ratio, we'll divide these two terms and we'll get the answer 7:32. So our correct answer would be option 4. Okay. Now the next thing is option the slide 8. In slide 8, we have the empirical and the molecular formula. Now, the difference between empirical and the molecular formula is, empirical formula is a formula which gives us the simple whole number ratio of atoms of various elements present in a molecule. While the molecular formula, it contains the actual number of atoms of various elements present in a molecule. Okay. So now the empirical and the molecular formula, it could be same, it could be different. For example, we have ethanol. Now the molecular formula of ethanol is C2H6O. While the empirical formula of ethanol is also C2H6O, because it is the most basic number of atoms that this particular molecular formula could contain. While in case of ethane, the molecular formula is C2H6, while the empirical formula is CH3. So this is the difference between empirical and the molecular formula. The empirical formula is the simplest whole number ratio, while molecular formula is the actual whole number ratio of atoms. Now, basically, I have explained this particular topic. Now, this particular topic I have explained with the help of a numerical, because I thought it would be more better to understand this with the help of a question. So basically here, we have to calculate the empirical formula of an oxide of iron, and the percentage composition of the two elements, that is the iron and dioxygen, are given to us. So we can just calculate this question with the help of simple mathematics. For example, we'll in first column we'll mention the elements, that is iron and oxygen. In the other, it is necessary for us to know the atomic masses of these elements, which is 56, and for oxygen, for O it is 16. Right, percentage composition is given to us. Now, please look at the fourth column, which is moles. Now, again, we'll calculate this with the help of the formula given mass upon molar mass. We will take the percentage composition to be the given mass to us, and we'll divide it by the molar mass. Okay. The fifth column is the most important. In it, we have to calculate the mole ratio. Now, how do we actually calculate the mole ratio is, please look at the fourth column in which I have mentioned the moles. Now, for all the moles of the elements present in a given molecule, what we'll do is we'll look at the minimum number, right? In case of iron, moles are 1.25. In case of oxygen, the moles are 1.88. Now here the minimum number is 1.25. So in order to calculate the mole ratio, we'll divide these numbers with the smallest number, that is 1.25. So for iron, our mole ratio would be 1. For oxygen, our mole ratio would come out to be 1.5. Now, as I have already said, that in empirical, that whether it's empirical formula or whether it's molecular formula, you can calculate them only when you know the whole number ratio, right? Now, since as we know that 1.5 is not a whole number ratio, in order to convert it into whole number ratio and the basic form, we'll multiply it with 2. Okay, so for iron, we'll get the simplest whole number as 2, while for oxygen, we'll get it 3. So the result, our empirical formula would come out to be Fe2O3. Okay. Now our next topic is the limiting reagent. Now limiting reagent is a reactant which is completely consumed when a reaction goes to completion, right? And through limiting reaction, now basically it is the limiting reagent through which we can calculate the production, or we can calculate the amount of product we have formed, right? And limiting reagent is basically the deciding factor of the reaction through which we can calculate all of the information. Okay, so basically here is a question through which we can understand this better. Now in this question, basically here it is given that 50 kg of nitrogen and 10 kg of hydrogen are mixed to produce NH3. Now this reaction is Haber's process. As you can see in the solution, N2 plus 3H2 gives 2 NH3. This is Haber's process. Now we have to calculate the amount of NH3 formed. This is the first part. And secondly, we have to identify the limiting reagent in the production of NH3. So if we will be able to calculate the limiting reagent, through the limiting reagent, we can calculate the amount of NH3 formed. Okay. Now please look at the solution. Here I have written the balanced form of the Haber's process, that is N2 plus 3H2 gives 2 NH3. Okay. Now you have we will calculate the number of moles of hydrogen. Okay, since it is given out to be 10 kg, we'll convert it into grams. And using the formula given mass upon molar mass, we will take 10 into 10 raised to the power 3 grams of hydrogen divided by 2 grams, which is the molar mass of hydrogen. And it would come out to be 5 into 10 raised to the power 3 moles. Similarly, we will calculate the number of moles of the nitrogen, right? So we'll convert the 50 kg into grams, we'll divide them with 28, which is the molar mass of nitrogen, and the respective number of moles will come. Okay. Now, as we can see through the equation that 1 mole of N2 reacts with 3 mole of H2 to give 2 moles of NH3. Okay. Now, here 1 mole of N2 reacts with 3 moles of H2. Now, since 1 mole of N2 reacts with 3 moles of H2, so the number of moles of H2 required to react with 17.86 into 10 raised to the power 2 moles of N2 would be, basically we will multiply this with 3, right? And we will get the answer 5.36 into 10 raised to the power 3 moles. Okay, so since the answer is coming out to be 5.36 into 10 raised to the power 3 moles, but if you look at the previous slide, the number of hydrogens are coming out to be 5 into 10 raised to the power 3 moles. Okay, and the hydrogen needed is more. So here hydrogen is present in the limiting quantity. Thus, hydrogen is the limiting reagent here. As I already said, that the reactant which is completely consumed when a reaction goes to completion is the limiting reagent. So here, since hydrogen is needed in the excess amount, but we have limited amount of hydrogen, right? So here hydrogen would be the limiting reagent. So we have our answer of the first part. Then we have to calculate the amount of NH3 formed. So we will calculate the amount of NH3 formed. Remember this, we will calculate the amount of NH3 formed with the help of the limiting reagent. Okay. So basically, here we have hydrogen as the limiting reagent. So since here, as you can see, since 3 mole of H2 is giving us 2 moles of NH3. So 5 into 10 raised to the power 3 moles of H2 would give us this much amount of NH3. 3.33 into 10 raised to the power 3 moles of NH3, right? And you can calculate the mass of NH3 by simply multiplying it with the help of the molar mass. You will be able to calculate the mass of NH3. And yes, here I have covered basically the 3 topics. In first, I've just explained the basic mole concept. Then I've explained the empirical formula and the molecular formula. And third one being the limiting reagent. So I've covered these 3 major topics in this session. So yes, and this is all. Thank you for your patient listening. Thank you very much.